After a substantial dose of hardcore popular science, let's take it easy and introduce some big shots in artificial intelligence. The first luminary we present today is Alan Turing. He should be a familiar figure to the general public in the computing world, associated with various things bearing his name, such as the Nobel Prize in Computing, named the Turingaward, Turing machine and Turing test, crucial measures for evaluating and testing artificial intelligence. During World War II, he played a key role in decrypting the German Enigma machine, contributing to the Allies' victory. Born in 1912, Turing showed exceptional talent in mathematics from a young age, becoming a STEM prodigy while pursuing his undergraduate degree at King's College, Cambridge. He published several mathematical papers, elevating him from an ordinary student to a research fellow in mathematics at King's College. He was honored with the prestigious Smith's Prize at Cambridge. In 1936, he published the paper on computable numbers, with an application to the Entscheidungsproblem, introducing the concept of the Turing machine, a universal model of computation. He later pursued a PhD at Princeton University, focusing on pure mathematics and early cryptography research. His mathematical career was interrupted by World War II when he was employed by the British Royal Navy. Under the surveillance of Mi-6, he successfully deciphered the German Enigma cipher machine, earning him the status of a hidden hero in the Allies' victory. This work made him a leading cryptanalyst, and his contributions in the field remain groundbreaking. However, due to secrecy, Mi-6 concealed the existence and achievements of the Turing team, revealing them only after decrypting classified files in April 2012, on the centenary of Turing's birth. Post-World War II, he engaged in research on the automatic computing engine ACE, marking him as an iconic figure in the fields of computers and artificial intelligence. It's worth noting that in the early stages, there was no clear distinction between computers and artificial intelligence. I'll delve into the relationship between artificial intelligence and computers, along with various contempt chain within the computer domain, in a separate article. Turing's research leaned more towards theory, mathematics, and philosophy than engineering, making his theories more accessible to the public. Some of Turing's achievements in computer science and artificial intelligence were made before World War II. For instance, the concept of the Turing machine appeared in his 1936 paper on computable numbers, with an application to the Entscheidungsproblem, which is also a mathematical problem, laying essential theoretical groundwork for the fields of computers and artificial intelligence. Some achievements came after World War II, such as the Turing test proposed in 1950 in his paper Computing Machinery and Intelligence. Due to his involvement in classified work, although he wrote many papers, most of his work was not formally published in scientific journals at the time but in internal reports, discussions, and some remained classified for years. From the decrypted parts, we know that he researched mathematical logic, which significantly influenced computer science and artificial intelligence. Pioneering research in artificial intelligence, particularly his famous paper Computing Machinery and Intelligence. Contributions to group theory and Riemann geometry as a pure mathematician. Interesting theoretical biology work, sometimes referred to as mathematical biology, in the paper Chemical Basis of Morphogenesis. He used sophisticated mathematical methods to study the distribution patterns of chemicals, which he called morphogens, determining the color or shape of biological forms, such as spots on a cow's coat or the distribution of raisin radiolaria and leaf arrangements. He attempted to explain the idea that physical and chemical laws can fully explain many facts of morphogenesis. Turing also laid the foundation for what later became known as mathematical embryology. He even attempted to use mathematical methods to study the structure of the human brain, estimating the amount of information a brain with a given number of neurons could store. He had a passion for sports and was a talented long-distance runner. Due to injuries, he failed to qualify for the Olympic selection. If he had focused on long-distance training, we might have seen a marathon world champion named Turing. He was also a homosexual and faced persecution for it. After enduring humiliation, he chose suicide at the age of 42. There are other theories about his cause of death, perhaps awaiting the release of certain classified files by the British government. Now let's briefly outline his life. He was a British prodigy, recognized as a computer scientist, mathematician, logician, cryptanalyst, and theoretical biologist. Acclaimed as one of the fathers of computer science and artificial intelligence. He was also a homosexual and a remarkable long-distance runner. After his homosexuality became public, he faced discrimination from society and ultimately chose to end his life at the age of 42. Due to his involvement in classified code-breaking activities, his extensive academic achievements were kept confidential by the government until they were declassified. Alan Turing is undoubtedly one of the foundational figures in the fields of computer science and artificial intelligence. Many people like to draw comparisons between him and John von Neumann. Both Turing and von Neumann were outstanding geniuses, but they differed in their contributions. While von Neumann oversaw the development of the first modern electronic computer, he humbly acknowledged that Turing inspired him, attributing the original achievements to Turing. Von Neumann admired and mentored Turing, and his contributions to computer science were outstanding. Turing's research on computer theory began with his 1936 paper, known as one of the earliest original studies in the field. He theoretically defined the computer, emphasizing that there could be various implementations. The widely recognized von Neumann architecture is just one such implementation, and other theoretical implementations remain within the scope of Turing machines. Therefore, Turing's contributions are considered fundamental and pioneering, forming the theoretical and philosophical basis of computer science and artificial intelligence. From this perspective, Turing's contributions to computer science and artificial intelligence are unparalleled. Therefore, Turing's contributions are considered fundamental and pioneering, forming the theoretical and philosophical basis of computer science and artificial intelligence. From this perspective, Turing's contributions to computer science and artificial intelligence are unparalleled. However, it's essential to acknowledge that von Neumann was an all-around talent in the field of science and engineering. He made significant contributions to pure mathematics, applied mathematics, physics, chemistry, game theory, economics, and other fields. Computer science was only a small part of his extensive body of work. Turing was a tragic genius and a behind-the-scenes hero. He had an introverted personality and was dedicated to his work. When his homosexuality was revealed, it was during the era of the Cold War and McCarthyism, and Turing faced persecution. He was unable to continue working in cryptography and computing due to societal prejudices. Despite his substantial contributions to Britain and the Allies, much of his work remained unknown to the public during his lifetime due to secrecy. In 1966, the Association for Computing Machinery (ACM) established the Turingaward, often referred to as the Nobel Prize of Computing. 55 years after Turing's death, on September 10, 2009, British Prime Minister Gordon Brown officially issued an apology to Turing on behalf of the world.